Okay, so here's the question, number 7, and it says the smooth vertical walls AB and CB are at right angles to each other. A particle P is moving with the speed u on a smooth horizontal floor and strikes the wall CB at an angle alpha. It rebounds at an angle beta to the wall CB. The particle then strikes the wall AB and rebounds at an angle gamma to the wall as seen on the diagram. The coefficient of restitution between each wall and P is E. Show that tan beta is equal to E of tan alpha. All right. All right. So here we are talking of beta and alpha, which technically we're talking about the first collision. So let's analyze the first collision, right? So I'll say here the first collision. And for the first collision, we are going to look at components before collision and after collision. What's the speed after the first collision? We don't have it. So let's say this is u. So let's say that the speed will be v. All right. So technically, we're saying before collision, if we look at components that are parallel to the wall, parallel components, for u, that component will be u cos alpha. So we have u cos alpha. And after collision, it will be v cos beta. So v cos beta. But we know that v cos beta and u cos alpha are equal to each other because the components that are parallel to the wall do not change. They're always equal to each other. So this component and this component are equal. So that's why I said v cos beta is equal to u cos alpha, and I'm calling that equation 1. Next, we look at the perpendicular components. Okay, for u, that's u sine alpha. And for v, that's v sine beta. V sine beta. But for v sine beta, we can apply the coefficient, the Newton's law of restitution to say is equal to E of u sine alpha, and we call that equation 2. So for the perpendicular components, we can use Newton's law of restitution to say technically we are using the fact that Vs is equal to E of Va. The relative speed of separation is the component of the perpendicular component after collision, and Va is the perpendicular component before collision. So technically, that's what we are saying here. So these two equations are important because we can actually say equation 2 divided by equation 1. All right. And if we do, on the left side, we will remain with tan of beta. And on the right side, the u's cancel, sine over cos is tan alpha. So it's E tan alpha. And shown, that's actually what they want us to show. Okay, what do you think of this?
It's okay, sir.
Okay, let's go on to the part B. On part B, they say, express gamma in terms of alpha and explain what this result means about the final direction of motion of P. Okay. Now, gamma in terms of alpha. So we're now talking about gamma, and gamma is on the second collision. So let's try to analyze the second collision, all right? So we're going to say here for the second collision. And for the second collision, we're going to have components before collision and after collision. I do this just to simplify it. It makes everything, be clear, in my own opinion. All right. And we look at components that are parallel and perpendicular. We will, okay? So also require the perpendicular ones. But let's start with the parallel components. Parallel to the surface, in this case, is the wall AB. We don't know what this is. So since we don't know what it is, we said U, we said V. So we can use W for this. Okay. So the component parallel to AB for V, remember this one is actually 90 minus beta. So it's V cos 90 minus beta. So V cos 90 minus beta. But cos 90 minus beta is the same as sine beta. So it's V sine beta. Okay, I hope you know this trigonometrical rule that cos of 90 minus something is the same as sine of that thing. Okay, so that's what I've used here. All right. The polar component after collision will be W cos gamma. So W cos gamma, and remember it's equal to V sine beta for the simple fact that the polar components do not change. And I'll call this equation 3 since we already have 1 and 2 above. Okay, so that's the first thing. For the perpendicular components, all right, before collision, we have V sine 90 minus beta. So V sine 90 minus beta is equal to, and now, since sine of 90 minus beta, you need to know this rule again. Sine of 90 minus theta is the same as cos theta. So this is the same as V cos beta. All right. And then for after collision, the component will be W sine gamma. All right. So W sine gamma here. And here we're going to use Newton's law of restitution to say that it's equal to E, all right, of V cos beta. Okay, let's call this equation 4. Okay, so we have those two nice, interesting equations. All right. Now, this side of things has got gamma, so it's fine. This one has got beta, and it's not looking good for us because they say gamma in terms of alpha. So going back, if we take equation 3, we have W cos gamma. V sine beta, V sine beta is EU sine alpha from equation 2. So we can use for it EU sine alpha. Yeah, did you see that? V sine beta is EU sine alpha. So where there's V sine beta here, I'm now using EU sine alpha. Okay. And equation, did you get that?
Yes, sir. Yeah.
Okay, good. Oh, good. We still have a bit of space. Then for equation 4, we have W sine gamma. And for V cos beta, V cos beta is actually U cos alpha. So it's like EU of cos alpha. All right. Okay. So we can actually now divide, okay, the equations. We can say equation 4 divided by equation 3 which will be tan gamma is equal to, cos of a sine is 1 over tan. The EUs will cancel. So 1 over tan alpha. This is gamma, all right. So we now have things like this, and this is a right angle. This angle is gamma. Actually, because they say tan gamma. So if this is gamma, then this has to be 1, and this has to be tan alpha. Okay, that's technically how it is. Okay. If we say tan alpha, it means this angle has to be alpha. So basically, this is the arrangement where we can see that alpha plus gamma is actually equal to 90 degrees. Okay, that's what alpha and gamma is. So they say express gamma in terms of alpha. It therefore means that gamma is equal to 90 minus alpha. Sorry, alpha. So that's how we do it. Gamma is 90 minus alpha. So this relationship can be illustrated this way. So we can give this conclusion. And therefore, this. Okay, I don't know if you're with me here.
Uh, so can you just explain how you do the triangle?
Okay, thank you. It's all right. Let me do that. Okay. Okay. So tan is opposite over adjacent, right? So if we have gamma here on opposite, we should have a 1, which is this. And on the adjacent side, we should have tan alpha. Is that part okay?
Oh, it's because of tan gamma, right? That's why
Yes.
you're having the gamma. Yeah.
Yes. So
Uh,
such an
what is
arrangement.
the other alpha?
So I know it's alpha because this angle has to be alpha because if I say tan alpha, it means I'm saying opposite over this will be the adjacent, right? So it will be tan alpha over 1, which is true. So that's what makes this angle alpha technically. Do you get that?
So tan alpha, so tan alpha of one, and one is so one. Tan alpha is opposite or adjacent here?
Yes, opposite over adjacent. So opposite is tan alpha, adjacent is 1. So tan alpha over 1 is just tan alpha. So it's true. So that makes that angle alpha.
Okay, so yeah, now it's okay.
Okay. Yeah. Is that all they're asking? So they say express gamma in terms of alpha and explain what this result means about the final direction of motion of P. The final direction of motion of P. So the direction of this, okay. We have established that gamma is 90 minus alpha. So this angle here is 90 minus alpha. If I were to draw a line that is parallel to AB that goes this way, so a line parallel to AB, this one, we know that there would be a right angle here, and this angle would be 90 minus alpha. Okay. And we actually can see that this angle here is also 90 minus alpha. Okay. So the angle between AB or a line parallel to AB, the angle it makes with this line is also the same angle the AB makes with this line, which technically means that these two lines are therefore parallel to each other. Okay. So it actually means that it's going in a direction parallel to the initial direction. Do you get the sense of that?
Yes, sir.
It's like if you have two parallel lines and a transversal, okay? The angle that the first parallel line makes with the transversal is equal to the angle it makes um with the other transversal. So technically, if this angle and this angle are equal, it means that these two lines are parallel. That's the kind of idea. So we can actually deduce that the final direction, which is this direction, is parallel to the initial direction. Parallel and opposite directions, though. So the question is asking, okay, oh, where's the question? Oh, yeah, explain what this result means about the final direction of motion of that. So can we say that the final direction of motion is parallel and opposite to the initial direction? Can we say that? Yeah, what do you think, Wagner?
So are you saying the value of U and W are the same?
No, parallel but opposite directions. Not the same, but they are the directions are parallel and opposite.
Yeah, they are parallel.
So we can say that the final direction, let me use the proper final direction is parallel and opposite the initial direction. Okay, let's move on to the last part. As a result of the two impacts, the particle loses 8/9 of its initial kinetic energy. Given that alpha plus beta equals to 90, find the value of E and the value of tan alpha. All right, so here we're talking about loss in kinetic energy. All right. When it loses 8/9 of its kinetic energy, what does that mean? So this should mean that the final kinetic energy is a ninth of the initial kinetic energy. What do you think?
So does it give the same meaning?
Yeah, it should have the same meaning because we're saying that it loses 8/9 of its initial kinetic energy, which means what remains is a ninth. The final kinetic energy is a ninth of the initial kinetic energy, since 8/9 of the energy have been lost.
Okay.
All right, so let's look at these kinetic energies. Let's start with the initial kinetic energy. For the initial kinetic energy, it's half mu squared straight on. For the final kinetic energy, if you take equation 3 and equation 4, I think we can find W with that. If we say equation 3 squared plus equation 4 squared, okay, if we say equation 3 squared plus equation 4 squared, then that will be, for equation 3 squared, that will be W squared cos squared gamma plus W squared sine squared gamma. That's the left side. Okay. That's the left side. And on the right side, it will be EU sine alpha squared plus EU cos alpha squared. So EU sine alpha squared plus EU cos alpha squared. So on the left side, we will be left with W squared. You know how cos squared gamma plus sine squared gamma gives us 1. It's fine, right?
Yes, sir.
And then on the right side, it's going to be E squared U squared, just E squared U squared. So therefore, the final kinetic energy is going to be half m W squared, which is half m E squared U squared. Okay, so we're going to say half m E squared U squared is equal to a ninth of a half mu squared. Okay, and so we technically have half m e squared u squared is equal to 1 over 18 mu squared. So to get e squared, we'll be saying 1 over 18 mu squared times 2 over m of u squared. Okay, so e squared is equal to 1 over 9 of mu squareds, they cancel. So e is equal to a third. So we have e being equal to a third. Okay, e being equal to a third. They also say we should find the value of tan alpha. And for the value of tan alpha, if we take the result we got earlier, tan beta is equal to e tan alpha. Tan beta is equal to e tan alpha. And remember, we've been told that alpha plus beta equals to 90. So we can say here, because what we're looking for is tan alpha, right? So we can say here tan beta, which is tan of 90 minus alpha, basically, because beta is 90 minus alpha, is equal to E, which is a third of tan alpha. Okay. Tan 90 minus alpha is sine 90 minus alpha over cos of 90 minus alpha is equal to tan alpha over 3, technically, which is the same as cos alpha over sine alpha is equal to tan alpha over 3. So basically, this is the same as cot alpha, which is 1 over tan alpha, is equal to tan alpha over 3, which leads to, if we cross multiply, tan squared alpha is equal to 3, which means that tan alpha is equal to root 3, right?
Yeah.
Okay, yeah, I think it's good if we look at it that way. So that's how we solve this problem.